So in this class, we will start the second chapter. Second chapter is basically the revision on the design of rectangular beams that are straight in plan as well as in elevation. Okay, so from this is a revision that was this is the chapter that was given in level 1. However, I believe that it is very important so that we revise some basic concepts in the design of RC beams. Okay, well, this chapter again consists of 4 main parts. Okay, the introduction, the design steps of RC beams, and there will be one beam design for flexure example, and there will be a beam design for shear. Okay, where in this shear we will also design for flexure. However, it will be very very fast. Okay, all the steps will be discussed here. Okay, let's start. So what's beam basically? Beam is a structural member that is designed to resist forces acting lateral to its axis. Okay, so each element will have its own axis, longitudinal axis. So if the load is lateral to the longitudinal axis, something like this, okay, this is the longitudinal axis or the element axis. If the load is perpendicular or lateral to this longitudinal axis, we will call it beam, because basically the primary effect of this load will be bending. So if the beam, if the element is primarily loaded with a bending effect, okay, we will say that is a beam. Well, there's a very critical point to be noted. It is that the orientation of the beam is not generally the orientation is generally horizontal. However, it's not always necessary to be horizontal. Okay, because sometimes it can be vertical and it can be beam because of this load. This distributed load, for example, is now laterally applied to the longitudinal axis of this beam, right? So the effect of this beam will be, the effect of this load will be bending. Okay, as we said, there will be a structure, there will be load, and there will be response. So this response will be in terms of bending. Okay, so the bending of this element rather than the compression effect, it will be suffering bending effect. Okay, so for this we will call this element is also a beam. Okay, however, if it is primarily loaded with compression, we will call it is a column. Okay, now it can be also such kind of continuous beam with this overhang and loaded like this, so this kind of thing will be a beam. Now the classification as per the Ethiopian code as well as the Eurocode is as follows. If an element has a length to depth ratio less than 3, okay, less than 3, we call it a deep beam. However, if it's greater than or equal to 3, it will be beam. Okay, beams must have a length divided by the depth of the beam greater than or equal to 3. Okay, otherwise we will call it deep beam. So the deep beam concept is not in the coverage of this course. Okay, is an advanced course and an advanced concept. So however, we are going to deal with the beam that we know. We may call it normal beam. Okay, so this is a sample example. Okay, this is a length 2 meter and the depth is 1 meter. So L by D will be 2 by 1, which is equal to 2, which is less than 3. So such kind of beams are called deep beam. However, if it's greater than or equal to 3, we will call it beam. Okay, now the concepts of the basic assumptions for beam theory will be implemented in this category. Okay, not in this category.